All right, divide by using synthetic division. So this is another extension of dividing by dividing polynomials. Now we're going to get into synthetic division, and synthetic division is a shortcut method of dividing polynomials using long division. Now, before we do this question, I want I want to take it way back when you were first taught how to divide whole numbers. For example, you had something such as we want to divide 5 into 49,600, excuse me, 4,967. We want to use long division. Now I want you to think about the process. The process to this. How do we divide? And when we divide using long division, we would say we want to divide 5 into 4, which it doesn't happen. We know that this is the first step where we would divide. So since 5 cannot divide into 4, so then we go to the next digit that's next to 4, and we're going to look at the combination of 49. Well, 5 divides into 49 9 times. And then the next step is we're going to take that 9 that's in the quotient area, and we're going to multiply. 9 times 5, which gives us 45. From there, it says we're going to subtract. 45 from 49, we have 4. Bring down then the next step would be to bring down. So we're going to bring down the 6. And then we start this process over again, where 5 divides into 46 9 times. 9 times 5 is 45. We subtract, and we have 46 minus 45, which is 1. And then we would bring down and start the process over again. 5 divides into 17 3 times. 3, then multiply. 3 times the 5, we have 15. Subtract 15 from 17, we have a remainder of 2. So before decimals were introduced and all of that good stuff, we left this answer as with the remainder, and we would write our answer as 993, remainder 2. Because if we wanted to check our work, we would take the 993 times it to the 5, which we would get 4965, and then we would add 2 to that to get the 4,967. So I want you to think about that, because today I'm gonna teach you a shortcut to long division when it comes to dividing polynomials. So here again, using long division, we have x squared plus 6x minus 16 all over x minus 2. Now let me say this. What we had before, the example that was given before, that was just working with numbers. Now we're talking about dividing by using long division with polynomials. And with polynomials, you know, it can be a monomial, binomial, trinomial. But as far as our divisor would have to be a binomial, trinomial on up, more than 2 terms, to use this long division. So you don't have to write this part out, but I want to show you what was why synthetic division is being used instead of long division. But before I show you synthetic division, let me show you long division. So our divisor is x minus 2. Our dividend, what we're going to put under the long division sign, will be x squared plus 6x minus 16. Now remember that process that we talked about. We divide, we're going to multiply, then we're going to subtract, we're going to bring down. So that's the process. So we're going to take the first term of the divisor and divide it into the first term of the dividend. So you're saying x divides into x squared how many times? This is what it looks like. X divides into x squared how many times? How would you reduce that? You would say x. So x divides into x squared x times. So we divide it. Now we're going to multiply. We're going to take the x that's in the quotient area and we're going to multiply it to our divisor. Our divisor has two terms. So you're saying x times x, which gives us x squared, and then x times negative 2, which gives us negative 2x. So we multiplied. Now we're going to subtract, meaning I'm going to subtract the x squared and the negative 2x. So as I subtract, what I put in the circle will be the signs that we're going to use. We're going to take the opposite because remember, if I put a minus sign in front of the x squared and parentheses around the x squared and the minus 2x, we would have to take that negative and distribute. So as we subtract, we change the signs. So the signs that I have circled are the new signs that we're going to use. So the x squared cancels out. Add your x's, 6x plus 2x. We have here 8x. And then the last step in the long division is to bring down. Now, we're not finished with this particular question because we need to see if x can divide into 8x. Okay? We need to finish the quotient. So 8 divides into 8x, which will be 8 times. So we're going to put plus 8. That's your divide. Then we're going to multiply 8 times x, we have 8x. Then 8 times minus 2, we would say negative 16. We multiplied, now we're going to subtract. So we're going to change the signs of that last row there of the 8x, the 8x and the 16. That becomes a negative 8 and then a positive 16. So the 8x's cancel out. And then we're left with negative 16 plus 16, which is a remainder of 0. So that's an indication to say that we've used all of our terms. We have a remainder of 0, and we're finished. So our answer, which is in the quotient area, is x plus 8. So you may be saying, Miss Lewis, I have no idea what's going on. This is a long way of doing this work. But I wanted to show you how this process of dividing polynomials, when your divisor is a binomial or more, what is the process? What does it take to get to this answer of x plus 8? Now, let me show you synthetic division.